Hi, I'm Dave of Urban Astro, and today we're going to go over the plate solving tab as part of the options in the setup here. Now, this tab isn't very complicated, but there are some decisions that you're going to have to make, and that's what we're going to talk about today. So you notice here that there isn't much going on in this tab. Like I said, you've got plate solving and then plate solver settings. And so essentially what Nina gives you is you're able to set up a primary plate solver, which is the plate solver drop down here, and you got a drop down of all these different plate solvers. So you got astronomy.net, you got local plate solver, PlateSolve 2, PlateSolve 3, all sky plate solver, ASTAP, the Sky X image link, and Pinpoint. And they're all different plate solving applications that you can use as your primary plate solver. And then you also have the option here, what's called a blind plate solver. And this is a slightly limited list. It doesn't have as many options as the plate solver does. So you have like Astronomy.net and local plate solver, all sky plate solver, ASTAP, PlateSolve 3, and Pinpoint. And so you have to kind of figure out what you want to use as your primary plate solver. Now, I take my scope to remote sites. So right off the bat here, when I come down here to plate solver settings, I got like astrometry.net, and I could use it when I'm at home. I could use it as my primary plate solver, but then I would have to go in and I would have to change that when I'm at a remote site, because it requires an internet access and you have to go and sign up on the website to get an API key. So right off the bat, I know that astrometry.net is not possible. For a local plate solver, I'm not using CYG Win as a plate solver, and that's a plate solver that's basically provided by astrometry.net for offline plate solving, and I just never played with this plate solver and never really got it to work. And so your mileage may vary. I guess you can download index files and all that, but I find that other plate solvers work just as well with minimal setup. I've used PlateSolve 2 before, and it's a good plate solver. The problem that I have with PlateSolve 2 is that it's not available to you as a blind solver. You're very limited on what you can use for a blind plate solve. PlateSolve 3 is a possible option as a blind plate solve. You can also use it as a primary plate solve, as it's right there, PlateSolve 2. For those of you who may not be aware, but PlateSolve 2 and PlateSolve 3 are products that come from PlaneWave. They're the folks that do the CDK instruments and the really high-end direct drive mounts, and they provide their own plate solving solutions. PlateSolve 2 is publicly accessible and used by the general public, and then there's a version of PlateSolve 3 that was specifically set aside for use in Nina, and I'll show you that, how to get to that here in just a little bit. All Sky Plate Solver and ASTAP are similar. I believe that they're actually from the same people. I may be mistaken, I don't know. I used All Sky Plate Solver when I ran APT, but I've since have migrated to using ASTAP, and I find that it generally works for most of my applications, for most of my needs. The SkyX image link, I'm unfamiliar with SkyX. I don't have SkyX. I don't use it, so I really don't know that much about it. I think if you have SkyX application that you can use it for plate solving, and that's essentially what this setup here is for. And then pinpoint, again, pinpoint is something that I am not at all familiar with, and it looks like it's related to astrometry.net and to AllSky PlateSolver, because you can see the AllSky API key here and the host. So I'm thinking that somehow these are related. Again, I don't know much about pinpoint. Now, part of the decision that you have to make is what are you going to use as your primary plate solver, your default plate solver, and then what do you want to set up as a blind plate solver. Now, what a blind plate solver is that if there's a failure of the primary plate solving mechanism, then it will try to continue to plate solve that particular captured image using the blind solver. And you can see here that there's a switch here for use blind solver on failures. Some people don't use a blind solver. If they can't plate solve with their primary application, then it basically stops their sequence until they do something, whether it's to check for things like autofocus, which I find is the majority reason as to why plate solves fail, is because autofocus was not run beforehand. And so in my sequences, I'll actually run an autofocus sequence first while the mount is still in a parked position, just so that way I know that at least I've got a decent focus before I try to center and slew, and have the need to run a plate solver, so that way I have minimal failures. But if I do have a failure, I'd like to have the blind plate solver pick up, and that's essentially what this switch right here is for. So I usually leave this on. It comes on as default, and you can see here that it defaults to ASTAP for both of those. ASTAP is, I think, the preferred plate solver. Now, how do you access the plate solvers? Where do you find them? Well, if you go out to Nina's website, so you come out here to Nina's website. Let's go to the website here. So here's Nina's website. If you go into the documentation and you go to like the release documentation, and you come over here, here is your documentation. This is for release. So anyways, you come over here to advanced topics, and part of the advanced topics is a page on plate solving. And this is a page that you probably should read through just to kind of help you understand how to set these things up and what you can run. And you noticed over here that there's a list of different plate solving options here that they talk about. So we're going to scroll down here. They have automated plate solving, and again, plate solving is also utilizing the sequencer to center on a given target and automate a meridian flip. Now, if you remember, so you come here to Nina, you go to options, and you go to your imaging tab, and you notice that right here in this section here, you've got this little switch right here. It's called recenter on flip, or recenter after flip, and this is where the plate solving piece is going to come in. If you have this clicked on as part of your meridian flip sequence, it's going to do a plate solving. It's going to try to plate solve and recenter based upon what your plate solve options are. So now let's go back to the documentation, and so we have there's things here to set up for plate solving to make sure that you've got the camera pixel size set up and your telescope focal length set up, because those are going to be required for good plate solving, for your plate solving to work. And those are going to be found here in this equipment tab, which I haven't really gone over yet just because we haven't set up a camera just yet, or set up a mount or anything else like that. And like this thing is going to be 600 millimeter is what the That's not the, yeah, it's a focal length, and the focal ratio is going to be 4. It's f4, and I'm just going to call it Quattro. And then my pixel size, I already know that I am using there we go, 3.6 bare pattern, yeah, none, because it's a mono camera. I'm using the ASI 2600 mm Pro, which I know is a pixel size of 3.6 micrometers, and it doesn't have a bare pattern because it's a mono camera, and bare patterns are for color cameras. And I know that this particular guy here is going to be 600 millimeters, and it's an f4 scope. So you go in there and you set up these parameters. And again, I would normally do this after I connect all my equipment. Then I go in here and I would work on setting this up. But just to show you where those particular settings are for your plate solving, it's really this right here that you need to focus on, and this right here that you need to focus on. Those two values are going to be required for you to do appropriate and adequate plate solving. Otherwise, your plate solving is going to fail on you. With those in mind, here are the recommended plate solving, and it recommends ASTAP, and it goes through here. It tells you what the benefits are, what the drawbacks are, and the recommendations. So it's recommended both as a primary solver and as a blind solver. And so I use ASTAP as my primary solver, as my default solver. And then you got astrometry.net, and here drawbacks is it requires an internet connection, and it's slow because again it's going over the internet, and it's not recommended as a primary solver, but it's okay as a blind solver as long as you have an internet connection. And then local plate solver, which is the local astrometry.net, it's not recommended as a primary, and it's not recommended as a blind. It's there if you wanted to use it, but it's not what Nina would prefer you to be using. Then we got All Sky Plate Solver. Again, it's basically a wrapper, as it says here, for the local astrometry.net client, and it says as a primary solver it's not recommended, and it's not recommended as a blind solver. And then we come to PlateSolve 2. It's very fast, does not require internet connection. It's slow plate solves when the mount location is far off the expected position and the focal length of the telescope is long. So if you're running this on like an SCT with like 2000 millimeter focal length, this is going to run slowly. So it falls into the recommended category as a primary plate solver, and you cannot use it as a blind plate solver for whatever reason. It doesn't work well as a secondary. It works okay as a primary. And then you see here PlateSolve 3. In PlateSolve 3, Nina has been kindly selected to add the new PlateSolve 3 program to his arsenal of plate solvers, courtesy of Dave Rowe. Dave Rowe is, I believe, the CTO at PlaneWave, and he's provided this for astrophotographers to use in Nina for plate solving. And you can see here that it is recommended both as a primary and as a blind. So what I do is I use ASTAP for my primary, and I use PlateSolve 3 as my backup. And again, the only time that it really goes to the blind plate solve is if for some reason I've got really bad tracking issues and there's star trails, and so ASTAP says I can't figure this thing out, or my focus is so off that it's not able to resolve where it thinks the telescope is pointing, because again, it can't focus on the stars because they're just blobs. That's what I generally find. And this PlateSolver 3, it's tested up to 12,000 millimeter focal length. So that's, I don't know very many people with a 12,000 millimeter focal length telescope, but hey, it works. And you notice here that there's a link that you can download it, and this link goes directly to a Dropbox which has this file, and you can click on that to download. And same thing, see ASTAP, where's ASTAP? Up here, here's a link to ASTAP, and you can click on that and you can download ASTAP. Now when you go out to ASTAP to download, here's the download page that you get here on ASTAP. Is you get a choice of Windows 64-bit and Windows 32-bit, Windows 11 64-bit ARM. I didn't realize that there was a 64-bit Windows 11 for ARM processors, but there is, and there's Linux there, and you can load this thing on Raspberry Pi 32 and 64, and of course Mac OS. I run this Windows 64-bit, so here's the actual program, and then you get to choose which database you want to install. And what I generally do is I use the D20 database, and you can see down here it shows you what the relative field of view that it can help to resolve stars in, and the D20 provides a fairly large database, 22,000 navigation stars per square degree. And because I'm in light polluted skies, I don't really need more than that. I could use the D50 database, I suppose, for when I go out to a dark sky site, but I find that the D20 works just fine, and so that's what I use. But you can download whatever database you want to use. If you're using this thing on a really wide field of view, like on an 85 millimeter lens or something like that, then you're probably going to want like the W08 database, which gives you a pretty wide field of view, or the G05 gives another wide view, and it does 500 navigation stars per square degree, but it uses 10-degree tiles, so it's a fairly wide, broad view. So anyways, I do the D20, and installing these things is pretty straightforward. You just download them. I've got them right here, and I'll just quickly walk through the setup here. It's really not that difficult. If you're running Windows, Windows doesn't like ASTAP, so it's going to ask you to go ahead and run it anyways. So you saw there that I clicked on, let me go back to that. I clicked on the more info right here, and then it allows you to run it anyways. So I'm going to go ahead and run it, and it's going to install quite quickly. I'm going to install it to C program files ASTAP, and I'm going to create a menu and create a desktop icon, and I'm going to just install this, and it installs fairly quickly, as you can see. I don't need to launch it. Okay, and then I got the star database. Now you have to remember where you installed ASTAP so you can install the star database. Boom, there we are. It might already, yeah, it's already figured out where ASTAP is at, and just hit install. And this will take a little bit of time, so I'll speed this up. Okay, so we've got the database and ASTAP set up. The last thing to do is PlateSolver 3.08. And what I'm going to do is go into my PC, and I'm going to go to my local drive, and I'm going to go to program files, and I'm going to create a new folder, and it's going to be, yeah, I need to continue. Okay, PlateSolve3, and open that guy up, and I'm going to copy everything here over. Continue. And this is going to take a little while, so I'll speed this up. Okay, now that that's all copied over, I think I need to do it to the whole folder. There we go. Properties, there we go. Yeah. No, I don't want to do that. I want to move this. Okay, now we go into security, and we're going to grant full control to the users. We're going to edit that, and for users, we're going to allow modify and hit apply, and it's going to apply that to everybody there. We'll now have modify. Okay, okay. And then we go back into PlateSolve3, and I'm going to do this config file right here, and I'm going to give it an extension, and I'm going to change the name, yes, because what happens is when we launch PlateSolve3, it's going to create a new config file. So we'll go ahead and we'll launch PlateSolve3, more info, say run it anyways, and here we are, and you notice here it says select the catalog directory. It wants to know where to find the catalog, so we're going to go into this PC, local, program files, PlateSolve3, and the first one here is going to be the Kepler, and we hit Kepler, and it disappears. I don't know why it does that, but it does. But it says status is okay. And then we go here for the next one, which is the Gaia 2. And we go into program files and PlateSolve3. And again, it's going to kind of depend on where you install it, but I install it in PlateSolve3. So there we go. So that's good to go. And then if you go back here to the instructions here for PlateSolve3, it says you need to start the executable once standalone and select the file configure directory. Add the Gaia 2, the Gaia DR2 location to the UD directory, and set the UCAC4 location to the Kepler. You will also need to set your location in view parameters. So we go to view parameters, and it's going to ask down here for our default location, and I am at 32.22.27. So space. Is it going to space it out for me? There we go. There we go. Okay. And we're at -112. -112.93. So 09, 09, and 03. And hit OK, and that's it. And we'll file exit, and you see that it creates its own PlateSolve config, which is why I renamed the original one with an ORG, because it's going to create a new file, a new configuration file. So now if I launch PlateSolve3 and go to configure directory, you see that my directories are right there. And if I go to view parameters, you see that my latitude and my longitude are there. So we're good to go. So those are all set up. So now we can go into Nina and we just point them to those places. So plate solving here, ASTAP, and then I'm going to set this to PlateSolve 3. I'm going to use blind PlateSolver on failures, yes. So I'm going to go into PlateSolve 3 and just tell it where to find PlateSolve 3. And it's going to be this PC, C, for me it's Program Files, PlateSolve 3, and there we are, boom. So we're good there, that's all set to go. And then for ASTAP, let's go and find ASTAP, Program Files, ASTAP, boom. And that's pretty much it. So search radius 30, I leave these as default. I don't see any need to have to change them. It works just fine with these defaults. Now, the only other thing that you need to probably take a look at is over here in these parameters that it's going to use when it's doing plate solving. So I usually like to do my exposure time at about 6 seconds. I generally like to use yeah, I don't have any filter set up. If I had filter set up, then they would be available here. And what I would choose is my luminance filter. So when I go and I set up my equipment and I actually attach my filter wheel, then this will be set to luminance. And binning 1, gain for my camera is 100, point tolerance within an arc minute, rotation tolerance within a degree, number of attempts and delay between attempts. I usually try to make that just a 1 minute delay, give a little bit of time for the scope to settle if it needs to settle or whatever, and I go through at least 10 attempts before it just says I can't figure out where I'm at. And that's pretty much the plate solving tab. So next time we're going to go over actually attaching equipment. I've got everything all set up, so now it's just a matter of attaching equipment and to be able to run it and configure it, and so that's going to be the next step in this process. So if you found any of this to be helpful, please comment down in the comments below. If you have questions about anything here, as best as I can figure it out, I'll let you know what I think or provide some guidance as best as I can, but please, I am no expert in this stuff. This is just how I configure this. This is how I understand it. So anyways, if you do find this to be at all helpful and useful to you, please feel free to go ahead and subscribe and hit the notification bell. And until next time, clear skies and happy guiding.